Assalamualaikum and a very good day, everyone. So we are about to present to you about the applications of heat transfer concept in our daily life and also industries. Next slide, please. So our group members consists of Muhammad Izham Ismail, Muhammad Hisham bin Muhammad Zahid, myself, Muhammad Hafiz bin Samsul Badrun, Muaz bin Abdul Malik, and also Ahmad Fathi bin Muhammad Hasbullah. So the application of heat transfer has been applied in our daily life and also industries around us. So let's check it out.
Okay, so my name is Ahmad Fathi. So the first one is what we found throughout our daily life is electric kettle. As you know, the electric kettle is a common household appliance electric designed to quickly and efficiently heat the water using electricity. Also, electric kettles are faster than stovetop kettles and often have a features like automatic shut off and control the temperature itself. Next slide. So what heat transfer concept involved in electric kettle? It actually involves three main things, which is conduction, convection, and radiation. Conduction is the movement of the heat throughout the surface. If the surface touches the surface, it will transfer the heat energy to the other material. So for the convection is when the heated water found with cold water, it will make a circulation pattern. That's what we call convection. And then for the last one is radiation. Radiation example is if we near the hot for example if we near the hot steel surface, we can still feel the heat from the steel itself. Okay, I think that's all from me. Thank you.
Okay, thank you, Ahmad Fathi. I will continue from here on. So let's move on to the technical questions. But first, let's read the question. So an electric kettle draws 2 kilowatt of electric power from the mains, but only 90% of its energy is transferred to the water by the convective heat transfer. The heating elements consist of flat circular plate with a diameter of 100 millimeter. When in operation, the heat flux at the interface and between the plate and the water, what will be? So the question asks us to find the heat flux between the plate and the water. So in order to answer this question, it is very simple and very direct. So next. So from this question, we know that the efficiency is equal to the power output over electric power. Hence, power output is equal to the convective heat transfer. There is a mistake in the slide. So convective heat transfer equal to the efficiency times the electric power, which is equal to 1.8 kilowatt. Then we have to measure the circular plate area, which is by using the formula of pi d squared over 4. Hence, we got 7.854 times 10 to the power of negative 3 millimeter square. Hence, heat flux is we can obtain heat flux by dividing the convective heat transfer with the circular plate. Hence, as we divided the the value that we have obtained previously, we get the heat flux is equal to 229.2 kilowatt per meter square. So this is the heat flux of the circular plate and the water. Next, I'll pass to the next presenter.
Okay, so next is for the industry application. So for industry, we have choose photovoltaic cell. I can call it PV cell. So photovoltaic cell is a solar cell which convert light energy directly into the electricity by the photovoltaic effect, which is a physical and chemical phenomenon. So they actually have been commonly used currently because technology has been discovered from time to time. So solar panel system is a renewable energy source which is infinite. So it can be used in all of Malaysia, as you know that Malaysia have a really stable climate, which we will see sunshine every day. So for the concept of heat transfer, so actually it's like the electric kettle application, but now I just want to explain how from the sunlight to become the electricity. Also for the first one application is for the absorption. So the PV cell semiconductor material typically made of silicon will absorb the photons from the sunlight. So this process is the first step in converting solar energy into electricity. The absorbed photon will transfer the energy to the material, promoting the generation of electron hole pairs. So the next concept is for the conduction. So once the photon transfer their energy to the semiconductor material, heat is generated within the PV cell. So this heat is conducted through the material moving from the hotter region to the cooler region. So the efficiency of the PV cell can be influenced by the ability of the material to conduct the heat itself. So the next concept is we will use is convection. So convection is the heat transfer process which occur due to the movement of the fluid, such as air or cooling medium. So in the convection, it helps to dissipate the generated heat and prevent the cell from overheating. So proper design of the solar cell, implement of the cooling mechanism such as heat sink or cooling fans. This can enhance the convection heat transfer and improve the overall efficiency of the PV cell. So the radiation is just like previous, the PV cell can also radiate the heat through thermal radiation. So if we near the PV cell, so we can still feel the heat from the cell itself. So next, I will pass to Hafiz.
Thank you, Muaz Malik. So here we come to the technical questions for the photovoltaic cell applications. So we will go through with the questions. The given value from the question, Ka is equal to 145 watt per meter times K, Kg equal to 1.4 K over M times K, and the PV cell itself is 0.5 meter long and 0.2 meter wide, and the temperature of the surrounding given is 25 degrees Celsius and the velocity is 5 meter per second. And there is also a Pratt number given equal to 0.706 and the kinematic viscosity. Next slide, please. Firstly, we will begin to calculate the Reynolds number to define the flow of the air. Is it a turbulent or a laminar? Since the obtained value of Reynolds is over 5 times 10 power of 5, so it is considered as turbulent. So, and then we proceed with calculating the Nusselt number to find convection coefficient value. We obtained 717, and then we found out the thermal conductivity value, the KF, equal to 2.69 times 10 power negative 2 watt per meter times K. We put all the values we obtained into the convection coefficient value, and we obtain the value convection coefficient, which is 38.6 watt per meter square times K.
So in conclusion, heat transfer plays a crucial role in various applications, whether in daily life or industries application, such as in electrical and also photovoltaic cells. So understanding the principles of heat transfer is essential for optimizing heat energy efficiency, maintaining comfortable indoor environments, and also to improve the performance of technological systems. By considering the principles of heat transfer, we can design and optimize systems to achieve desired outcomes while minimizing energy consumption and environmental impact. So that's all for our presentation. Thank you for listening.
Thank you.
Thank you.